So the next topic that we are going to see today is called as relative stability. Relative stability. Okay. So this relative stability, if you just want to sum it up, it is nothing but total amount of, or we can say percentage of total oxygen required. So it is just expressed as total amount of oxygen required for the oxidation. So definition point of view, if you want to write it down, it is defined as this relative stability. It is defined as ratio of ratio of so it is a ratio of two similar quantities. So it is a ratio of oxygen available to oxygen required. Now for what oxygen is required? For satisfying first stage BOD. First stage BOD, that is carbonaceous BOD. It is expressed as percentage of total oxygen required. Percentage of total oxygen required. So the relative stability, so it is generally denoted by SR. Okay. Now the formula, we'll try to write it down here. So SR, population equivalent, is equal to oxygen available in wastewater. Okay, oxygen available in wastewater divided by oxygen required for first stage BOD. First stage BOD. That means oxygen required for the total oxidation of biological content or organic content. So we can write it as YT divided by L naught. So this YT we can write it as L naught into the power 1 minus e to the power minus kT into T, and this L naught is initial organic content. Okay, so this L naught and everything we have seen in the BOD value. So you can just see this diagram, BOD mechanism. In the previous lectures this is covered. Okay, so L naught is the initial organic content. Okay, so if we just solve it, we will get the value as 1 minus e to the power minus kT into T. So this is the value for population equivalent. So as it is given in percentage, so we have to just multiply it with 100. So the net formula becomes SR is equal to 1 minus e to the power minus kT into T. Minus kT into T. In percentage it is into 100. So this T value is the time of incubation. And it is in days. So in India we generally practice it for two times. The one is for 20 degrees Celsius. The one is for 20 days. Okay, so one is T is the time in days, and one is for 20 degrees Celsius, and that we call it as T20. Okay, so for 20 degrees Celsius we name this T as T20 degrees. Okay, and the second temperature is 37 degrees Celsius, and we name this as 37. So for this the formulas are already derived. See, the main formula is this. Okay, So the main formula that is required at our level is this, but if we supply the, if we just enter all these values and substitute the E value also, so this formula will get upgraded to like this. So relative stability at 20 degrees Celsius, so this will be 100 into 1 minus 0.794 to the power T20 to the power T20, where T is the number of days. Similarly, for 37 degrees, that is if we substitute the 37 here, we'll get it 1 minus 0.6 to the power T37. T37. Okay, so it is not T multiplied by 37, it is T37. So these are all the formulas related to relative stability. So maximum first you should learn the definition here and this first formula, that is oxygen available in water by oxygen required for first stage BOD, and after calculating it will be 1 minus e to the power minus kT into T. So based on this only the questions will be asked mostly. So that's it from the relative stability concept.